In the unending quiet of the cosmos, where darkness is not an absence of light but the very canvas of existence, there are islands of impossible grandeur. Galaxies, each a swirling continent of 100 billion suns, drift in a silent, patient ocean of space-time. They are the great elders of the universe, their spiral arms like the rings of ancient trees, telling stories that span billions of years. At the heart of each of these cosmic titans lies a secret, a point of absolute command. A supermassive black hole. Not a monster, but a monarch. A gravitational anchor that gathers gas, shepherds stars, and conducts the grand symphony of galactic life. For eons, we believed this bond to be unbreakable, the most sacred and stable relationship in the universe. We looked to the heavens and saw order, a predictable waltz of gravity and light. And then, we saw 3C186. 8 billion light-years away, a beacon of ferocious light blazed in the dark. It was a quasar, the brilliant death scream of matter being consumed by a galactic core. But this king was not on its throne. It was a fugitive, a heart torn from the chest of its galaxy, hurled into the void at a speed that defies comprehension. It is a ghost on the run, an exile from its own kingdom, trailing the fires of its own glory behind it. This single, displaced point of light shattered our understanding of cosmic stability and posed a terrifying question: what force in the universe is powerful enough to cast out a god from its own heaven? What could make a black hole, the very definition of inescapable gravity, run? Tonight, we journey into the heart of this cosmic mystery. We will bear witness to a cataclysm of unimaginable scale and uncover the story of the loneliest object in the universe. Close your eyes. Let the darkness of your room become the darkness of deep space. Let our story be the stars that ignite within it. Now, let's begin. Music. The story begins not with a bang, but with a whisper of ancient light. A stream of photons, having traveled for 8 billion years, finally completed their journey, ending their long pilgrimage in the cold, unblinking eye of the Hubble Space Telescope. These photons were messengers from a distant past, carrying a portrait of a galaxy cluster as it was when our own solar system was nothing but a cold, undifferentiated cloud of dust and gas. Astronomers were not looking for an anomaly. They were conducting a census, charting the grand architecture of the universe, mapping the locations of these massive galactic families. Among the faint, ghostly smudges of light, one point shone with an unnatural ferocity. It was catalogued as 3C186, a quasar. The name is mundane, a simple entry in a celestial ledger, but what it represents is anything but. A quasar is the most luminous object in the known universe, a lighthouse burning across cosmic oceans. Its light is not born from the gentle fusion of stars, but from the violent, chaotic maelstrom of an accretion disk, a swirling vortex of superheated gas, dust, and shredded suns, all spiraling into the waiting maw of a supermassive black hole. This is the sound and light of a monster feeding, and its brilliance can outshine its entire host galaxy by 1,000 times. But as the data from Hubble was processed, a detail emerged that was deeply unsettling, a discordant note in the celestial harmony. The brilliant point of light, the quasar, was not where it should be. It was not nestled in the warm, dense center of its host galaxy. Instead, it was displaced, offset by a staggering 35,000 light-years. To comprehend this scale, imagine our own sun suddenly appearing in the empty space halfway to the Andromeda galaxy. The very heart of this cosmic island had been moved. The galaxy itself appeared disturbed, its structure hazy and distorted, like a watercolor painting left out in the rain. It looked wounded, its gravitational center, its very soul, torn away. The initial observation was a moment of profound cognitive dissonance. It was like finding a mountain peak floating miles away from its mountain range, or the Earth's core orbiting in the place of the Moon. The laws of physics, as we understood them, demanded that the most massive object in a galaxy should reside at its gravitational center, the bottom of the gravity well it creates. Yet here was a supermassive black hole, 1 billion times the mass of our Sun, adrift in the galactic suburbs. It was a king in exile, still wearing its crown of light, but ruling over an empty kingdom of void. The first question was simple, yet its implications were vast. Was it truly moving, or was this some strange, static illusion? Was it a prisoner pushed to the edge of its cell, or a fugitive in the midst of a great escape? The answer would require more than just a picture. It would require listening to the very song of its light. To understand the flight of 3C186, we must learn to see the universe not just with our eyes, but with our ears. Light, like sound, travels in waves. When a source of sound, like an ambulance siren, moves toward you, its sound waves are compressed, raising the pitch. As it moves away, the waves are stretched, lowering the pitch. This is the Doppler effect, a familiar phenomenon on Earth. In the cosmos, light behaves in precisely the same way. Light from an object moving away from us is stretched to longer, redder wavelengths, a phenomenon called redshift. Light from an object moving towards us is compressed to shorter, bluer wavelengths, a blue shift. The spectrum of light from any celestial object is embedded with fingerprints, dark lines called absorption lines, which correspond to specific elements in its atmosphere or surrounding gas. These lines have a known, fixed position in the spectrum. By measuring how far these lines have shifted, astronomers can calculate, with astonishing precision, the object's velocity relative to us. When the team of scientists pointed their instruments toward the host galaxy of 3C186, they measured its redshift. The light told a story of majestic, stately motion. The galaxy, along with its entire cluster, was receding from us, carried along by the grand expansion of the universe itself, like a ship on a cosmic tide. But when they focused on the light of the quasar alone, they heard a different song. Its light was also redshifted, but it was more redshifted than its parent galaxy. This additional shift was not from the expansion of the universe. It was the signature of a personal, localized velocity. The quasar was running away from its home. The calculations that followed were staggering, bordering on the unbelievable. The supermassive black hole was moving at 2,000 kilometers per second. That is over 7 million kilometers, or 4.5 million miles, per hour. At this speed, you could travel from the Earth to the Moon in under a minute. It is a velocity so immense that it is almost impossible for a galaxy's gravity to contain it. The black hole was not just displaced, it was traveling at its galaxy's escape velocity. It was breaking free. This was no longer a mystery of position, but a mystery of motion. It was a confirmed fugitive, caught in the act of a cosmic jailbreak. The image of the offset quasar was the crime scene, the redshift was the confession. The quiet awe inspired by the initial image now gave way to a more urgent, dramatic inquiry. An object with the mass of 1 billion suns, the gravitational anchor of an entire galaxy, had been accelerated to a speed that shreds the imagination. The search for a cause began, a quest to identify a force capable of such a monumental act of cosmic violence. What celestial engine, what prime mover, could impart this much energy? What could give a black hole, the epitome of immovability, a kick of such impossible magnitude? The first instinct of any astrophysicist, when faced with an object moving at an unusual speed, is to look for the influence of gravity. The universe is a grand cosmic billiards table, where massive objects are constantly interacting, pulling and pushing on one another in a complex dance. Perhaps, the scientists reasoned, the story of 3C186 was a simple one of a gravitational slingshot. The hypothesis was straightforward and elegant. Imagine a third, massive body, another galaxy, or perhaps a second supermassive black hole, that passed close to the host galaxy of 3C186. In this cosmic flyby, a three-body interaction could have occurred. The interloper could have gravitationally grabbed the quasar's black hole and, through a complex exchange of momentum and energy, flung it outward, much like how our space probes use the gravity of Jupiter to accelerate towards the outer solar system. This scenario is well understood and happens on smaller scales throughout the universe, governing the orbits of stars in clusters and planets in binary systems. It was a plausible, almost comforting explanation, as it relied on the familiar, clockwork mechanics of Newtonian gravity. However, as the team modeled this scenario, the explanation began to unravel. The sheer scale of the event created insurmountable problems. To eject an object as massive as 1 billion suns at 2,000 kilometers per second would require an impossibly perfect and powerful interaction. The hypothetical third body would need to be extraordinarily massive itself, likely another galaxy of comparable or greater size. Furthermore, The geometry of the encounter would have to be exquisitely fine-tuned, a cosmic bullseye struck from billions of light-years away. When astronomers looked at the environment around 3C186, they found no evidence of such a perpetrator. The galaxy cluster it belongs to is relatively sparse. There was no smoking gun, no massive galaxy nearby that could have acted as the gravitational slingshot and then receded. The scene of the crime was conspicuously empty. Moreover, a slingshot event of this magnitude would leave other scars. It would have dramatically disrupted the host galaxy, stripping away vast clouds of gas and flinging stars out in long, visible streams. While the host galaxy of 3C186 was indeed disturbed, its morphology did not perfectly match the specific kind of damage a high-speed flyby would inflict. The slingshot hypothesis, while elegant in its simplicity, felt increasingly hollow. It required too much coincidence, too perfect a cosmic alignment, and left behind no corroborating evidence. The universe is rarely so neat. The search for a cause had to go deeper, beyond the gentle pull of distant objects and into the very fabric of spacetime itself. The answer was not in a push from the outside, but in a violent, explosive recall from within. To find the true engine behind the flight of 3C186, we must turn our attention to one of the most exotic and powerful phenomena in the universe, gravitational waves. For most of history, we conceived of space as a static, empty stage upon which the drama of the cosmos played out. But Einstein's theory of general relativity revealed a profound truth: space and time are not separate, nor are they a passive backdrop. They are woven together into a single, dynamic fabric called space-time. Massive objects, stars, planets, galaxies, do not simply sit in this fabric, they warp and curve it, and this curvature is what we experience as gravity. A planet orbiting a star is like a marble rolling around a bowling ball placed on a rubber sheet. Now, imagine what happens when the most massive, densest objects in the universe move. When they accelerate, they disturb this fabric, creating ripples that propagate outward at the speed of light. These are gravitational waves. They are not waves traveling through space, they are waves of space itself. They are the tremors of reality, the shudder of space-time in response to a cosmic cataclysm. For a century, they were purely theoretical, a ghostly prediction of Einstein's mathematics. But in 2015, the LIGO experiment detected them for the first time, hearing the faint chirp of two black holes merging over a billion light-years away. Humanity had grown a new sense, the ability to hear the silent song of the universe. This discovery opened a new window into the most violent events the cosmos has to offer. And it provided the key to unlocking the mystery of the runaway quasar. The new hypothesis was far more dramatic than a simple slingshot. It proposed that the supermassive black hole at the heart of 3C186 was not a single, ancient entity. It was the newborn product of a colossal merger. The story, then, did not begin with an ejection, but with a collision. A long time ago, two separate galaxies, each with its own supermassive black hole at its core, were drawn together by their mutual gravity. Their journey towards each other would have taken hundreds of millions of years, a slow, inexorable drift that culminated in a spectacular, transformative union. This event, the merger of two galaxies, is the crucible in which the most massive galaxies in the universe are forged. And at the heart of this crucible, a far more intimate and violent drama was about to unfold, a drama whose final act would send a shockwave not just through the newly formed galaxy, but through spacetime itself. The kick that launched 3C186 was not delivered by another object, but by the fundamental structure of reality, recoiling from an event of unimaginable power. Music. Imagine two great spiral galaxies, majestic islands of light, each hundreds of thousands of light-years across. For eons, they existed in peaceful isolation, their stars tracing calm, predictable orbits around their respective cores. But the subtle, patient hand of gravity was at work, pulling them across the intergalactic void. As they drew closer, their shapes began to distort. Long, ethereal arms of stars and gas, known as tidal tails, were drawn out from their disks, like silk threads pulled from a tapestry. The first pass was not a direct collision, but a graceful, sweeping encounter. Stars did not crash into one another, the space between them is too vast. Instead, their gravitational fields intermingled, a silent handshake that irrevocably sealed their fates. They swung past each other, but they could not escape. They were now bound in a cosmic dance, a gravitational embrace from which there was no release. Over the next few 100 million years, they would fall back together, pass through each other again and again, their structures becoming increasingly scrambled with each passage. The elegant spirals dissolved into a chaotic, turbulent sea of stars, a single, larger, and more disordered elliptical galaxy. But while the stars engaged in this grand, chaotic ballroom dance, a far more focused and deadly encounter was taking place at the center. The two supermassive black holes, the former hearts of their now devoured galaxies, began their own final spiral. Pulled by the immense gravity of the new galactic core, they shared orbital energy by flinging away nearby stars, sinking deeper and deeper towards the center. Eventually, they found each other. 2 points of infinite density, each with the mass of hundreds of millions of suns, were now locked in a tight, decaying orbit. They were two voids, circling each other in the heart of the storm they had created. As they spiraled closer, their speed increased, whipping around each other at a significant fraction of the speed of light. And as they did so, they began to scream. Their scream was not made of sound or light, but of pure gravitational energy. They were churning the fabric of space-time, radiating away their orbital energy in the form of powerful gravitational waves. This was the ghost song of their impending doom, a rising crescendo of ripples in reality, carrying away the energy that kept them apart. The final moments would have been a frenzy of unimaginable violence. In the last few minutes, they would release more energy in the form of gravitational waves than all the stars in the observable universe combined. It was a power surge that shook the very foundations of the cosmos. Then, silence. The two event horizons touched, merged, and became one. A new, larger, and more massive black hole was born from the union of two. But in the physics of this union lay the secret of the kick. The birth of this new black hole was the moment of creation for the force that would cast it into exile. The key lies in a single word: asymmetry. If the two merging black holes had been perfectly identical, the same mass, the same rate of spin, and aligned in a perfectly symmetrical orbit, the gravitational waves they produced would have been emitted equally in all directions. The final, merged black hole would have remained serenely at the center of the new galaxy, a quiet monument to the violence of its own birth. But the universe is rarely, if ever, perfect. It is messy, chaotic, and asymmetrical. It is almost certain that the two merging black holes were not identical. One was likely more massive than the other. They were likely spinning at different rates, or their spin axes were tilted at different angles relative to their orbit, like wobbly tops. This asymmetry in the initial conditions had a profound consequence. It meant that the gravitational waves, the scream of their merger, were not radiated uniformly. More energy, more momentum, was blasted out in one direction than in the opposite direction. It became a focused, directional beam of gravitational radiation. This is the heart of the recoil mechanism. Think of a rocket. It expels hot gas out of its nozzle in one direction, and by Newton's third law, for every action, there is an equal and opposite reaction. The rocket is propelled in the opposite direction. The merger of two asymmetric black holes creates the ultimate cosmic rocket. The focused, one-sided blast of gravitational waves is the exhaust. The newly formed black hole is the rocket. As space-time itself is radiated away in one direction, the black hole recoils, or kicks, in the other. It is a kick delivered not by matter, but by the warping of geometry. It is a push from the departing ghost of its own past. The magnitude of this kick depends entirely on the specific configuration of the merger. In the most extreme, superkick scenarios, with optimally misaligned spins, theoretical models predict recoil velocities of up to 5,000 km per second, more than enough to explain the 7 million km/h speed of 3C-186. The puzzle pieces were finally falling into place. The disturbed shape of the host galaxy was the scar tissue of a recent merger. The incredible velocity of the quasar was the result of a powerful, asymmetric gravitational wave kick. The story was no longer about a mysterious force pushing the black hole out, but about the black hole's own violent birth pushing itself out. It was a self-inflicted exile, a consequence of its own creation. Let us now pull our focus back from the moment of the kick and survey the aftermath. We return to the scene of the crime, the wounded galaxy left behind. 8 billion years ago, it was a place of transformation and renewal, the site of a grand merger that promised the birth of a larger, more majestic stellar city. But the promise was broken. The recoil of its newborn heart left it in a state of profound crisis. A galaxy's supermassive black hole is not merely a passive anchor. It is an active, vital organ in a complex ecosystem. It regulates the galaxy's growth. Through processes known as feedback, the intense radiation and powerful jets from a feeding black hole can heat up or blow away the cold gas in the galactic center. This prevents the gas from collapsing and forming too many stars too quickly, acting as a thermostat that ensures the galaxy's long, stable life. The galaxy of 3C186 has lost its thermostat. Its central engine has been ripped out. In the immediate aftermath, there might be a burst of frantic star formation in the core, as the gas, now unregulated, collapses under its own gravity. But this is a death rattle, not a sign of life. Without the black hole to shepherd and stir the gas, the center will eventually become quiescent and barren. The galaxy will slowly and quietly fade. It has been lobotomized, its core rendered inert. The tidal tails, those ghostly arms of stars flung out during the merger, will continue their slow journey into the intergalactic medium, eventually dispersing until they are invisible. The chaotic jumble of stars in the main body will, over billions of years, settle into a more stable, but less vibrant, elliptical shape. It will become a red and dead galaxy, populated by old stars, with no new ones being born to replace them. It is a body that will continue to exist, but its soul has departed. And that soul, the Quasar 3C186, is now on a journey of its own, a solitary pilgrimage through the cosmic dark. It shines not with the light of its own stars, but with the fires of the matter it managed to drag along with it. The accretion disk, the swirling vortex of gas that makes it a quasar, was gravitationally bound to the black hole and was carried along for the ride. This is why we can see it. It is a lighthouse that has been torn from its coastline, yet its lamp remains lit, a beacon marking its own lonely path into the unknown. The galaxy it left behind can only watch as its heart recedes, a fading point of light that carries the memory of what it once was. The journey of the rogue black hole is one of profound, almost unimaginable loneliness. It travels through the intergalactic medium, the near-perfect vacuum that separates the great islands of matter. Here, the density of gas is less than 1 atom per cubic meter. It is an ocean of almost pure nothingness. Yet, the black hole is not entirely without sustenance. It plows through this tenuous medium, its immense gravity capturing any stray atoms it encounters, adding them to its dwindling accretion disk. This allows its quasar to keep burning, though it will be a shadow of its former glory. For now, it is a brilliant spectacle, a billion solar mass cannonball trailing a wake of superheated gas. But its time as a luminous quasar is finite. The fuel it carried with it from the galactic core will eventually be consumed. The accretion disk will thin, its light will dim, and the quasar will flicker out. What happens then? When its fires die, it will become what it truly is, a naked singularity, a point of infinite density, now utterly invisible. It will be a true ghost in the machine of the cosmos, a rogue supermassive black hole wandering the dark, detectable only by the way its gravity bends the light of objects far behind it, a needle in a cosmic haystack of impossible scale. Its fate is uncertain, a story with many possible endings. It may wander for eternity, an unseen predator in the great dark, never again to be anchored to a home. The universe is vast, and the chances of it encountering another galaxy are infinitesimally small. It could drift for trillions of years, long after the last stars in the universe have burned out, a lonely relic of a more vibrant era. Or perhaps, by a stroke of cosmic luck, its trajectory will intersect with another galaxy. It would not be a gentle arrival. It would plunge through the galaxy's disk like a bullet, its gravity wreaking havoc, scattering stars, and disrupting gas clouds. If the galaxy is large enough, and the encounter is slow enough, it might be captured. It could sink to the center of this new galaxy, devouring its native, smaller black hole and establishing a new monarchy. It would be a usurper king, taking the throne of a foreign land, its violent past forgotten as it begins a new cycle of galactic regulation and growth. This second chance, however, is a remote possibility. The more likely fate is one of perpetual exile. A journey without a destination, through an emptiness so profound and so vast that it transcends our concepts of time and distance. The story of 3C186 is not just the story of an object, but the story of a path, a line drawn through the void, signifying a departure from which there is likely no return. The discovery of a single runaway supermassive black hole is more than just a cosmic curiosity. It is a fundamental paradigm shift in our understanding of how galaxies live and die. For decades, our models of galactic evolution assumed a stable, codependent relationship between a galaxy and its central black hole. We believed they grew together, lived together, and faded together. The black hole was the immovable center, the constant around which everything else revolved. 3C186 proves this assumption wrong. It reveals a universe that is far more dynamic, violent, and unpredictable than we had ever dared to imagine. It tells us that the hearts of galaxies can, in fact, be torn out. This implies that the empty space between galaxies may not be so empty after all. It may be populated by an unseen host of rogue supermassive black holes, the silent, invisible exiles from countless ancient mergers. We can only see the ones like 3C186 that are still actively feeding and shining as quasars. How many more are out there, their lights having long since gone out, moving through the void as dark, silent gravitational phantoms? The number could be in the thousands, or even millions. These wandering behemoths would have a subtle but significant effect on the evolution of the cosmos. They would stir the intergalactic medium, heating it in their passage. They could occasionally pass through smaller dwarf galaxies, disrupting them or even stripping them of their stars and gas, effectively sterilizing them. They are a population of cosmic nomads, a hidden variable in the grand equation of cosmic structure formation. This discovery also forces us to reconsider the life cycle of galaxies themselves. A galaxy that loses its central black hole is set on a path of slow, inexorable decay. It becomes a member of the living dead. The existence of recoiling black holes provides a new mechanism for quenching star formation and creating the red and dead elliptical galaxies we see throughout the universe. It is a more violent, more sudden death than the slow starvation we had previously envisioned. The universe we inhabit is one of constant flux, a place of both creation and expulsion. Gravity, the force we associate with binding things together, is also intimately linked to the mechanism that can tear them apart. The merger of two black holes is an act of gravitational creation, forging a more massive object. Yet that same act can generate a gravitational recoil that leads to cosmic divorce on the grandest scale. It is a beautiful and terrifying symmetry. The story of 3C186 is a reminder that even the most massive and seemingly permanent structures in the universe are subject to chaotic, unpredictable events. The cosmos is not a clockwork machine. It is a wild, untamed frontier, and we are only just beginning to glimpse the true violence and majesty of its laws. Music. And so, our journey comes to a close. We have traveled across 8 billion years of light and shadow, from a single, curious point of light in a telescopic image to a grand cosmic saga of colliding galaxies, a screaming chorus of gravitational waves, and a heart cast into an endless exile. The core mystery has found its resolution. The fugitive quasar, 3C186, is not the victim of some external bully, but the product of its own violent birth. It is the cannonball recoiling from the cannon, propelled by a focused blast of spacetime itself, a consequence of the messy, asymmetrical union of two black holes that came before it. It is a story of cosmic cause and effect, where the most fundamental forces of nature, gravity and the very geometry of reality, conspire to enact a drama of unimaginable scale. We began with a question: what could unmoor the heart of a galaxy? We found the answer in the ghost song of a merger, in the asymmetric scream that followed the silence. But as with all great discoveries, this answer opens the door to more profound questions. We are left to wonder about the unseen population of these cosmic wanderers, the silent kings ruling over kingdoms of empty space. We are forced to reconsider the stability of our own galactic home, to recognize the latent violence simmering beneath the serene beauty of the night sky. The universe is not a gentle place. It is a realm of titans, where forces beyond our earthly comprehension can unmake what took eons to build. The story of 3C186 is a testament to that power, a story of creation, collision, and consequence, written in the language of light and gravity across a canvas of space-time. We are left with a sense of awe, not just at the scale of the event, but at our own ability to piece the story together from a few faint photons that traveled for longer than the Earth has existed. It is a humbling reminder of our place in the cosmos, tiny, fleeting observers, yet capable of comprehending the epic tales of the giants that surround us. And now, as you rest in the quiet darkness, reflect on the silent violence and majestic power we have witnessed tonight. What would you have done if you could witness it? If you could see two galaxies merge, and watch as their newborn heart is cast out into the eternal night? Would you have felt terror at the sheer destructive force, or a profound sense of wonder at the raw, untamed engine of the cosmos at work? Perhaps both. For that is the nature of the universe, terrifyingly powerful, and impossibly beautiful.